Hi guys, in today's video we have a differential equation to solve. So we want to find the general solution of this equation. So we're gonna let y equal to x to the power r, right? Now this implies that the first derivative of this, so dy dx, is gonna be r times x to the power r minus 1, right? Now the second derivative is gonna be d squared y dx squared is going to be equal to r times r minus 1 x to the power r minus 1 minus 1, so r minus 2, right? Now we can substitute these into our equation. So we have the x squared times d squared y dx squared is this one here, so times r minus 1 x to the power r minus 2, this one, plus 3x dy dx, so x to the power r minus 1, and then plus y, we said that is equal to x to the power r, this is equal to 0, right? Now if we expand, this is going to be equal to r times r minus 1, and here x to the power 2 x to the power r minus 2. Using properties of exponential, 2 and 2, we're gonna add up this, so 2 and 2 are gonna cancel out and we have just r left, right? So x to the power r, so plus 3, here same thing, so we have r x to the power r, because basically here we have a 1, and if we add up the exponent, 1 and 1 are gonna cancel out, so just r remain, so plus x to the power r is equal to 0, right? Now we can factorize because we have factor x to the power r, so this implies that x to the power r times r minus 1, then we have plus 3r plus 1, this is equal to 0, right? Now here x was greater than 0, so basically we can divide by this, so we have, this implies r times r minus 1 plus 3r plus 1 is equal to 0, which is basically this one here. Now we can expand again, so we have r squared minus r plus 3r plus 1 is equal to 0, right? And this implies that r squared plus 2r plus 1 is equal to 0, right? Now we can find r because this is a quadratic equation, so r is going to be equal to, here we have a 2, so we can use this formula, minus b half, which is 1, plus or minus square root of b half square, so which is 1 square, minus ac, so here a is 1 and c is 1, so minus 1, and that gives us that r1 is basically equal to r2, which is just minus 1, because this is gonna cancel out, we have 1 minus 1, which is 0, so we have two roots, two non-distinct roots, so r1 is the same as r2, right? We know that the general solution of this differential equation is y is equal to k1 y1 plus k2 y2. In this case we know our y1 because we said that at the beginning, we said that y is equal to x to the power r, so y1 is going to be x to the power r1, right? So in this case y is equal to k1 x to the power r1, that is this one here, right? So minus 1 plus k2 y2. Now we need to find y2, right? We can find y2 using the method of the reduction order, because basically our y1 is x to the power minus 1, right, which is this one here. Now, using the method of the reduction order, our y2 is going to be equal to y1 times integral of w over y1 square, right, where w is equal to the exponential of minus integral of p of x dx, right? So if we go back to our equation, so this was our equation, right? We can write it down in standard form. So since we know that x is greater than 0, so we can divide both sides by x squared, so that we have the coefficient of d squared y dx squared equal to 1, right? So if we divide both sides by x squared, we have that d squared y over dx squared plus 3x over x squared, so it's going to be 3 over x dy dx. Then we have plus 1 over x squared y, this is equal to 0, right? So this is the standard form. So in this case, our p of x is equal to 3 over x, which is the coefficient of our dy dx, right? So our y2 is going to be equal to y1 that we already know, which is x to the power minus 1, right? So x to the power minus 1 integral of our w is this one here, right? And we know p of x, which is this one, so our w is going to be equal to e to the power minus integral of p of x, which is 3 over x dx, right? And we have on the bottom we have y1 squared, so x to the power minus 1 squared, so minus 2, right? So this is our y2. So this implies that y2 is equal to 1 over x, because x to the power minus 1 we can write it down as 1 over x, right? So we have integral of e to the power minus 3. If we take this minus 3 out, we have minus 3 integration of 1 over x dx, and then we have x to the power minus 2, right? Now integration of 1 over x is natural log of x, right? So this is equal to 1 over x integral of e to the power minus 3 natural log of x over x to the power minus 2. By the way, natural log of x, because we know that x is greater than 0, so we don't need to put the absolute value, right? So this is going to be equal to 1 over x integral of x to the power minus 3 over x to the power minus 2, because we can use properties of logarithm if we put this on the exponent. So exponential and logarithm are mutually inverse, so we're gonna be left with x to the power minus 3, which is this one here. Now this implies that our y2 is gonna be equal to 1 over x integral of, here we have x to the power minus 3, x to the power minus 2. Using properties of exponential, we need to subtract minus 2 from minus 3, so we have x to the power minus 1, right? Because it's going to be minus 3 minus minus 2, which is minus 3 plus 2, which is minus 1. By the way, they're all with respect to x, right? So with respect to x, this one is with respect to x, this one as well, and here as well with respect to x. Now integral of x to the power minus 1 is integration of 1 over x, which is basically natural log of absolute value of x, but x is greater than 0, so there is no need to put the absolute value. So our y2 is going to be equal to 1 over x, then natural log of x, right? Now we know our y1, and we know our y2 as well. So we said that the general solution is this one here, so we can copy it here. So our general solution is k1 y1 plus k2 y2. We have found it, so it's this one here. So this is the general solution, and if we factorize, so we have y is equal to this x to the power minus 1 is 1 over x, so we can factorize 1 over x. So we have k1 plus k2 natural log of x. So this is our general solution.